Welcome back. This is the second lesson recording for IM2, October 12, 2020. So in your groups, you are able to explore the different shortcuts to see if any of them are valid. So what you should have hopefully come to a conclusion is that triangle similarity, AA similarity, is a valid similarity theorem. If two pairs of corresponding angles are congruent, then the two triangles must be similar. Okay, so if you just have two corresponding angles, so 35 here, 35 here, and 80 here, that's a second pair here. So one pair, 35, 35, a second pair, 80, 80. Then if you just have those two, then the triangles are congruent. We don't really care about any of the sides, okay? We don't care what the ratio of the side length are, because it does not matter. If you have two angles that are congruent, then it is sufficient. So triangle DEF is similar to triangle TRS by AA similarity. That's how you write that. Just like when you're writing congruence statement, you would use congruence symbol, but this time we're using similarity symbol. And again, the D, vertex D has to correspond to T, vertex D has to correspond to T, vertex E corresponds to R, and vertex F corresponds to S. That's important. So using AA similarity, so if you have this diagram, do you know if the two triangles are similar? You are given that this angle is congruent to this, you're given that angle B is congruent to angle Q. Is that enough? The answer is yes, they are, because the angle-angle similarity theorem, angle-angle similarity theorem, you just need two angles to be congruent, and that's enough. Okay, what about this one? Okay, are these triangles congruent? Please answer in private chat. Okay, what do we have here? We have 71, 71 here, so that matches up. Do we have any other angles that match up? No, we have one pair of congruent angles. Okay, remember we're talking about one angle from one triangle and one angle from the other triangle. These are not two pairs. This is one pair of corresponding angles that are congruent. So no, because only one pair of angles are congruent. What about this? Answer in private chat. Are these two triangles congruent? Maybe, but we don't know for sure. How can we know for sure? We need to calculate the missing angle using triangle sum. Remember, if we have two angles, two of the angle measures, then we can figure out what the third angle is, because all the angles must add to 180 degrees. So 180 minus 32 minus 52 is 96. So we figured out that angle P has to be angle 96 degrees. And that means that we have 96 and 96 match up, 32 and 32 match up. So we have two angles that are congruent. So by angle-angle triangle similarity theorem, yes, those two triangles are similar. All right, what about SAS? Okay, so SAS, triangle similarity says if two pairs of corresponding side length have the same ratio. Okay, so if the 8 and 16, they have the same ratio, and 12 and 24, they have the same ratio. And the included angle between the two known sides with the proportional sides, then the two triangles must be similar. Okay, so that's side, angle, side. Just like the way you labeled side, angle, side in congruence theorem, you are doing the same. You have the side that are proportional. In this case, they are not congruent, they are proportional. And the angle that are congruent, equal, and another side that are proportional. That means you have some same scale factor that I can multiply to this to get to 16. So I'm multiplying by 2, and 12 by 2 is 24. So they are proportional, because 16 over 8 is 2 and 24 over 12 is 2, and plus measure of angle E is equal to measure of angle C. So the triangles are similar. Angle DEF is similar to triangle ACB by SAS similarity. Okay, your turn. Answer in private chat. What do you think? Are these two triangles similar? Okay, how do you know? Okay, you should be figuring out, okay, we have matching angles. Okay, how are they related? 8 times what is 12? Okay, or 12 divided by 8 is what? 24 divided by 16. Are the ratios the same? Okay, so you need to match up the short side with short side. Okay, so that's the easiest way. Between 12 and 24, which is the shorter one? It's 12, right? So match up the 12 with 8. So 12 over 8 or 8 over 12 is 2 over 3. Okay, and then match up the longer side with longer side. So that's 16 with 24. So 16 over 24 is 2/3. Since the ratio is the same, yes, by SAS similarity is satisfied. So those two triangles are similar. What about this? See if you can tell me. Are the two triangles similar? Well, maybe two sides and one angle. But no, the angle is not between the sides. Okay, so it's not the included angle. So it's not SAS here. It's angle, side, side, isn't it? Angle, side, side. So the angles are the same. And yes, they are, the sides are proportional. But this is angle, side, side. And remember, it was not, angle, side, side is not a triangle congruence, nor is a similarity congruence. So, what about side, side, side? If all three pairs of corresponding side lengths have the same ratio, then the two triangles must be similar. Okay, so we don't, at this point, we don't care if we have the sides that are proportional or they have the same ratio. Okay, 5 times 2 is 10, or the same scale factor. 4 times 2 is 8, or 3.5 times 2 is 7, or if you put it as a ratio, 10 over 5 is 2, 8 over 4 is 2, and 7 over 3.5 is 2. So all the ratios are the same, or the scale factor for each of the corresponding side is multiplied by 2. So that means triangle ABC is similar to triangle PQR by SSS similarity. Okay, we know, when we know that the two triangles are similar, then we know that the angle, corresponding angles must be congruent too. Okay, what about this? Can you tell me in private chat, are they similar? Maybe by SSS. Okay, that's what we know. Let's see, need to set up and check all ratio sides. Match up the short side to short side and long to long. So looking at this, which is the shortest side? It's the 14. Looking at this, which is the shortest side? It's 10. So match them up. Okay, so 10 with 14 with 10. So 14 over 10 is equal to 7 over 5. And 21 over 15, those are the medium size. Okay, 21 over 15 is same as, and then finally 28 over 20. So just match them up and write them down, and then you simplify. Okay, you can certainly use the calculator. You get 1.4, but it has to be exact. If it's 1.41 and the other one is 1.40, then there are different numbers. So even close enough is not good enough. This does happen to be 1.4 and 1.4, so I know that they are similar. Now, what if I use 10 over 14 instead. Okay, so if I use reverse, but I just need to be consistent. If I am going to go from the big triangle to smaller triangle, then it will be 14 over 10. But if I'm going from smaller triangle to the bigger triangle, it will be 10 over 14. It's still going to be the same. It's going to be approximately 0.715, 0.715, 0.715, and they are exactly the same. So we know for sure that they are similar, okay? But again, like I said before, they have to be exactly the same. It can't be off by 0.01. If then it's not good enough. Please answer in private chat, are these two triangles similar? Maybe, because that's what we're given, are 3 side. So set up and check all the side ratio, short to short, long to long. 10 with 20. 10 over 20 is 1 over 2. And 15 with 25. And 21 with 21. 21 with 35. They correspond to each other, right? So because they are the longer side. And look at the ratio. They do not match up. 1/2 and 3/5. At this point, do I even need to go to the third ratio? No, I don't, because they failed already. Okay, so I don't even have to go there. Alright, so then triangle congruence shortcuts. Let's just summarize what we figured out. Okay, remember, this is the triangle congruence. Remember, this is the congruence. We said that side is a congruence, side angle side is a congruence, and ASA is a congruence, and SAA and HL were the congruence shortcuts. Okay, let's not get confused with similarity. Okay, if we remember all of this, is there a way to remember similarity shortcuts? Well, the similarity shortcuts are SSS, SAS, AA, and HL. Okay, so look so SSS is a congruent shortcut as well as it's a similarity shortcut. SAS is a congruent shortcut, and it is also a similarity shortcut. ASA and SAA, they have 2 angles. So at this point, we don't really care where the side is, because when you know 2 of the angles, we actually know the third side. So as long as we have 2 angles, that's ASA or SAA, we're good. We don't really care where the third, we don't need to know the third side. Okay, so and HL is again similarity, and just the way SSA, that's the bad word here, was not a congruence shortcut, SSA is also not similarity shortcut. And this is where you are going to take notes on the different rules. So please pause the video and take notes of or summarizing what we've figured out. And so when do we use it and what to check? You check, so for AA similarity, check both pairs of corresponding angles are congruent. For side angle side, check angle pairs are congruent, and then calculate the ratio of both corresponding sides and check the ratios are the same. And for the side, calculate the ratio of all 3 corresponding sides and check ratios are the same. Okay, so when we are going through examples, you are going to take inventory of measurement information in diagram. And when you're talking about inventory, you're seeing what you have. Okay, what are the information we're given, and what are the applicable shortcuts? No, to decide. No, I don't know enough to decide similarity, or yes, I have hope. Do everything in what to check. Okay, so please copy this down and please try to solve them to see are they similar or not. Okay, I am going to go through the answers in the next lesson recording.